Hello everyone and welcome to a new e-learning course. My name is Mohammed Marwan from Technology Academy and today we are going to talk about linear regression algorithm. Mainly here in this training we are aiming for explaining the mathematical background of this algorithm, which is considered to be one of the most famous algorithms available for machine learning. Many people knows how to use it, so here I'm going to concentrate on the mathematical part. So whenever you use it, you know what you are using, you know how it works if you are going to use it maybe for Python programming. Fine, so let us start. What we are going to cover here, first of all, we are going to understand the concept of regression. We will talk about the parameters, the assumption for linear regression, the error function which we are going to use, and how to optimize it using gradient descent. Gradient descent is a very important, we can say, optimization algorithm, which is going to lead for improving the accuracy of our model. We are going to see mathematically how it's possible to improve the model performance, and also at the end, to understand the whole concept, we're going to have a numerical example which is going to make the concept very much clear for us to understand what is linear regression and how it really works. Before we go through the details, I just want to give you, we can say, a helicopter view about machine learning types. Basically, machine learning types is are divided into two different types, which is supervised and unsupervised. I'm not going to go into the details. If you want to know more about it, you can attend machine learning training, which is going to cover many algorithm under both. But here in this short session, we are going to focus about a very special part coming under supervised learning, which is regression. And under regression, we will be talking about one algorithm, which is linear regression. Maybe in some other e-learning courses, we can focus on some more algorithms. Okay, do let me know what kind of algorithms you want me to explain, and I will be ready to explain it. Fine. But in this session we will talk about linear regression, which is coming under regression, which is coming under supervised machine learning type. Okay, when it comes for regression, let us assume I have a kind of columns. The first column, let us say, is the age, and the second column is the salary. Fine. So I have these two columns. These are, some of the data which I have in my department, maybe HR department. And what I have is I have, the age of my employees and the salary which it's offered for them, right? Now what I want to do is I want to know the relation between the age and the salary. Am I really giving the salary based on the age? Is there any relation between the age and the salary, putting in mind that both of these attributes, they are what? They are numerical attributes. These are not the discrete attributes. We are not talking here about male or female, the gender, for example. We are talking about an attribute which is having a scale. When it is having a scale, this is where we use regression. Regression is one of the techniques of machine learning which is aiming for predicting a continuous value. Continuous value can be, for example, here the salary, it can be 100, 1,000, 10,000, 100,000, correct? When I have a scale, okay, so that means I can apply regression. So regression aiming for predicting a continuous value. That value can be related to marketing, it can be related to sales, it can be related to engineering, and we will have examples about that. So if I want really to understand the relation between, for example, the age and the salary, so that any new recruitment, I can see the age, and by using linear regression, I can predict what is the best salary which is suitable for him as in terms of age, right? So regression is the process of analyzing and understanding the relation between two attributes and more. We can have maybe here we are just comparing between two columns, but in reality we will actually work with the 20, 30, maybe 100, more than 100 columns. But here, just to simplify the idea, I'm just giving you example of two columns. We can call this X, means the input column, and what I want to predict is the salary, and the salary we will call it Y. Fine. So usually when I'm using machine learning supervised technique like linear regression, I have usually input columns and output column. Here my input is age, and what I want to predict is the salary. Let us assume I have a historical data, and I'm using this data here in a scatter plot. So scatter plot will have, for example, two axes because I have two columns. The first axis, or the x-axis, is going to represent the age, and the y-axis is going to represent the salary. So what I can do is I can just draw this, data or visualize the data using scatter plot. And what usually we do, even from, a high school, we know that the moment we put it into a scatter plot, what is the next, task for us is to draw this regression line. So this is the most important step. Why? Because the moment I draw the regression line, now you give me any value, for example, here 5, okay? And what I can do, I can just draw this vertical line, right? Until I touch the regression line. And then now if I want to know the corresponding Y value, I can just go horizontally. And then now I can know what is the best salary in terms of, or as per his age, correct? So I don't need to have 5 in my original data. Let us assume I have 6 and I have 4. But because of this regression line, I was able to find, the salary even for the value which is in between, for example, right? So what is the benefit of this line? The benefit is now by using this line, I can predict, the Y value by, by just using, the if by just having an input, X columns, right? And by just using this line, I can predict the Y value, correct? So this is the concept of regression using linear regression algorithm. Now, how this can be used or where we can use it in many industry. Like for example, in real estate, if I have a property and I want to sell it, what I can do is I can sell it in term, or I can, let us say, choose the price in terms of the size, in terms of the area. If you are talking about a residential apartment, the number of washrooms, the number of bedroom, the size, etc., etc. So we can predict the best price as in terms of these attributes. So these attributes will be my input and my output is going to be the predicted final price. Also for predicting the stock required, okay, let us assume that I want to know how many or how much stock I need for next quarter or for next year. So I can do this kind of prediction using also a regression algorithm. For marketing also, if I want to know the best price for a certain product, let us assume that I'm coming out with a new product and I want to choose the best price. Instead of me choosing it by myself, I can make it automated by using, for example, linear regression, and we can just let the algorithm decide or recommend for us the best price, in term, or the best price based on a certain input columns, based on a certain input column. Now, in terms of telecom, since we are in telecom industry, how this can be also applied for telecom? Now, for telecom industry, as you know, we are providing a lot of services, right? In terms of e-life, in terms of, fiber services, mobile services. So, if, for example, let us assume that I want to predict the future customer required data rate, okay? Using mobile network, using 4G, 4.5. I want to know for next year, what will be the, the data consumption of my customer, what they will need. Fine. So also I can do something like this using regression. Let us assume that I want to predict the next year required budget. So budget, as you know, it is also a continuous number. It can be 100,000, it can be in millions. So since it is also a range or a scale, that means it is a regression problem. So I can do this kind of, a prediction using linear regression. Also, if I have a new surface in our industry, we are coming with a new surface, we can also predict the price using linear regression. So whenever you want to predict a continuous value, put in mind that you need to use a regression machine learning type. Okay, so for us to draw this line, I believe everybody knows the straight line equation. The straight line equation looks like this. So it is y equal p naught plus p1x, or you can also write it p plus mx, or c plus mx. Choose whatever you want, right? This is the straight line equation. Now, x and y, it will come from usually my data. So I can have, for example, x and y, like the age and the salary, right? And what about b0 and b1? These are what? These are the parameter which is going to decide how the line will be positioned. For example, let us assume that I want to draw this line. There are multiple, ways to draw it. I can draw it like this. I can draw it like this. I know my drawing is not perfect, but just for the sake of explanation, right? So I can draw n number of lines. Now the secret here in linear regression is to draw or how to draw the best line. Because if you are going to choose a certain line which is not that much accurate, you will end up with a wrong output, correct? So what we are aiming for, we are aiming for, drawing the best line possible, which is going to give us the best output in terms of accuracy. Now, how we can position or choose the best, line? We can do that by using two parameters. The first parameter is what is B naught or B or C, whatever you want to call it. This is actually the y-intercept. The second one, which is B1, or you can call it M also, this is the slope. And if you remember what is the slope, this is the slope. It is y2 minus y1 over x2 minus x1. This is the equation of the slope. And the the intercept is where that line is what is in fact intercepting or crossing the y-axis, right? So here in this case, for example, we can say that P naught is what is 30, correct? So we can, by tuning actually the slope and the y-intercept, we can decide where that line will be positioned in my data. Fine. So here this equation, we call it simple regression equation. Why? Because it in fact it's suitable for in case we have one input and output. But let us assume that for me to predict the price of a villa, I am not going to predict the price based on the size only. I will predict the price based on the size, based on the number of rooms, based on the area, etc., etc. Correct? So I have a lot of different attributes. It's not only one attribute which will lead for the answer. We can have 10, hundreds of attributes so that I can predict finally. Correct? So in case I have multiple attributes, the equation will be as the following. So we will have a different slope for each and every input value, but I will have one y-intercept for the whole linear regression line. So here I just want to show how choosing M and C, which is the slope and the intercept, can change the position of the line. So here for the first one, what do we have? We have the slope equal to 0. So you can see that the line is positioned horizontally. And C is equal 40. That's why it is in fact crossing y-axis with 40 as a value. Fine. And then the second one, we have M equals 0.8. That is the slope. And as you can see, it is, having a sort of an angle. It's upward. And C is equal 0. That's why it is passing from, the origin point. Here we have M equals 0.8 and we have C equal 40. As you can see, the line shifted a little bit, up so that it can cross Y equal 40. Right? So as you can see, I can, position or control the position of the line based on two parameters, based on the slope and based on the intercept. And again, this, examples which I'm giving you, or this algorithm which we are studying, this is something which we had it already in school, right? But where is the important part here, which is making it sort of, intelligent or part of machine learning? The most important part here is to understand which line is the most, suitable line. So if you are going to do such a thing manually, you will not be able to find the best line. It is impossible to find it by yourself manually as a human. Why? Because in reality, we don't have only one input and one output. In reality, we will have multiple input, multiple attributes which will lead for a certain prediction, right? So to draw that multi-dimensional graph and then selecting the best line, it's not going to be possible. Even if you have only one input and one output, as you can see here in this graph, there are n number of lines which I can draw. How I can know or how I can choose the best line? This is the tricky part in linear regression. Fine. So to choose that line, you need to know how to tune two parameters, which is M and C. If you are going to find the best value of M and C, you will be able to draw the best line possible. Don't forget that in reality, we will not have 6 or 10 or 100 value. We can have values in hundreds. We means in terms of rows, right? we can have values in hundreds, we can have in thousands, right? This is why we need a sort of an algorithm to make it easy for us, and linear regression can do it beautifully. So as you can see, we in fact start with a very, we can say far line, okay, inaccurate line, and we keep on changing the value of M and C so that finally we can reduce the error, fine, and increase the accuracy by providing or by finding the best line in terms of my data. So I keep on changing the value of M and C until my line will finally reduce the error, okay? And then, the moment it will find the best value for M and C, it's going to stop and it will decide that this is now the line which we can use for a prediction. The assumption which we need to, or the requirement which we need to always keep for linear regression is what? First of all, linear relationship between the dependent and independent value. Means we need to have a value, for example, x and y, and these two variables or two attributes need to be what? Need to have a sort of a correlation. For a correlation means when x will increase, for example, y should increase, okay? Maybe not at the same, we can say factor, but there should be some correlation between them. Even if it is not strong, but the correlation is one of the requirements of linear regression. Maybe when x will increase, y will decrease. This is also a correlation, but we call it negative correlation. In case we have such data with us, we can use linear regression. The second requirement is if I have multi-dimensional data, means if I have multiple input columns, these input columns, for example, I have x1, for example, I can have x2, x3, these columns, input columns, should not be correlated with each other. The column need to be correlated with the output, but the input column together, this is what we call it, multicollinearity, okay? This should not happen. If in case we have two columns correlated with each other, we need to do, or we need to choose maybe one of them, okay, to keep. Otherwise, we don't need to keep both of them available. Okay, so how usually we can calculate the error? If you notice here, I said we can just, choose different values of M and C until the error will be reduced. Now, how we calculate the error, this is what we are going to explain here. You all agree with me that if, for example, we are going to find the y value for 2, okay, we can just, come here and draw the line. We will see that it may be going to be 44 or 43, correct? But if we are going to go as per the original data, this is the original data without using the regression line. The original data is what? Is going to be 52 maybe, correct? So this difference here, we can consider it as an error. Here also there is a small error. Here there is an error. Here there is an error. So this is how we usually calculate the error. Fine. The summation of all of this error is going to be the total error finally. So to solve it or to calculate it, we have multiple matrices. Here we are explaining one of them, which is MSE. MSE is mean square error. Mean square error. Basically, it is just subtraction, okay, between the actual y value and the predicted y. What is the meaning predicted y? For example, here, what do we have? We have 50, and the predicted one, it was what? It was 43. So we can say 50 minus 50, sorry for this, 50 minus 43. Okay, fine, to the power 2. Plus the second point. We can see here also there is an error. So we are going to repeat the same for all the observations. Fine. The summation for this, and then after that 1 over n. N is the number of observations. Let us assume that in our data, I have 100 of observations. Observation means rows. Fine. So that means it's going to be divided over 100. That's why we say mean. Because finally we divide over the number. That's why we say mean. And why we say square? Because we are going to square the difference. Fine? I hope that it's clear. Mean square error is one of the most famous metrics when it comes for error calculation, but it might be not the best, but it is one of the best. Okay? Now, after we calculate the error, let us assume that the error, for example, it is 10,000. Now, how I can reduce this amount? How I can reduce it? We can reduce it, as I said before, by choosing the best value for M and C, correct? But the question is, how I can choose the best value of M and C? This is where we use gradient descent. Again, gradient descent, it's sometimes complicated to understand, but I will try here to explain it step by step so that it will be easy for you to understand it. Gradient descent, let us assume that this is the error, okay? And what I said if I will choose the best value of M and C, which is the slope and the intercept, means I will be able to draw the best line, correct? I will be able to draw the best line. And how we can draw the best line? By changing the value of M and C. So what is happening using gradient descent? In a gradient descent, what we are aiming for? We are aiming for searching. Let us assume we want to optimize the value of the slope. So what we will do? We will choose different value of the slope, and every time we change the slope, we are going to calculate the error for that. Fine. So let us assume M, it was, for example, 3. And the error for that, it was, for example, 1000. Now I will change M, I will keep it, for example, 2. And then when I calculated the error, now it is 500. Which one is better? Of course, now it's better for me, if I want to finalize it, is to choose the second one, M equal 2. So like that, the algorithm, or which is gradient descent, will try to go and search for example, between maybe 100 value until 1000 value, maybe more than that. So it will keep on changing the value of the weights or of the parameter M and C together. So we will keep on changing the values of M and C, and every time we change, we calculate the error. Every time we change, we calculate the error. Again, what we are aiming for? We are aiming for minimum error possible. Minimum error, how we calculate it? As I said before, we calculate it by mean square error. So if we are going to get a very small value here, minimum value, this is where we need to choose what? The corresponding M and C parameter to draw the best line. So if we are going to visualize it, it will look something like this. So this is this is actually we can say the graph of gradient descent. The x-axis will be, for example, M, and the y-axis will be the error. And let us assume that we choose first of all M randomly. Let us assume M here is for example 10. Fine. What we want, this 10 is having a high error, correct? What I want to do is I want to change the value. I want to change the value of M until I reach here. Why? Because this is the place where error is minimum. So I want to find this value, which is going to, for example, here in this case, it will be, let us say, 50. So I want to reach to this value, because in this value, I will get the minimum error. This is the idea of gradient descent. Keep on changing the values, okay, and calculating error. Change and calculate the error. And then finally, I will see which value was having minimum error. I will choose that value as a final value. I hope that it's clear what is gradient descent. Gradient descent is very important, fine, because it is, one of the, techniques which is used not only for linear regression, for so many algorithms under machine learning and, deep learning. Now let us go for the numerical example. Here, what do we have? We have the same data, or the same, problem what we were talking about, predicting the salary in terms of age, right? So what is our objective here? We want to apply linear regression algorithm so that we can predict the salary in terms of age, correct? What we have here is the historical data. And again, the first step we should do is always, we should just, convert this data or visualize it using a scatter plot. Right? So if I am going to visualize it using a scatter plot, the observations looks like this. The moment I see this observation, immediately I know that there is a correlation between the age and the salary. And don't forget that this is one of the requirements for us to apply linear regression. Why? Because if the observations are like this, so it is spread here, in different, places in this, plot, that means there is no correlation. In this case, I should not use linear regression. Maybe I should use another algorithms. Now, what we will do is, After we, draw the observations, my job is to draw or to find the best line possible, which is going to lead for minimum error, means I will have a very accurate, predictions. We are going to do that manually, so that we can understand the mathematical, perspective out of it. So let us see how we are going to do it. To do this kind of, computation, we will go through different iteration, and as I said before, we will keep on changing the value of m and c and calculate the error, and then we will know what is the best value of m and c, which will lead for minimum error possible, right? So now I'm going to show you the first iteration, how it is possible to apply linear regression along with gradient descent. So the way to do it is, first of all, I need to start with a line equation, right? Straight line equation, which is y predict, which is the prediction, of course, equal mx plus b. M, again, m is what? M is going to be the slope, x is going to be the input value, y is the prediction, and b is the intercept. So this is actually what is available here in this equation. We need to start with this equation, number one. Also, what we need to do, as I said here in this slide, I said we need to start with a random value of m and c. So this is what I am doing here. What we need to do, we will assume or choose randomly any value of m and what, and b or c. Fine. So we will choose here m equal 10 and b equal 300. Now in reality, this is also what is happening. I don't care where I will start, because at the end I'm going to search for the best combination of m and b, which will lead for minimum error possible. So for me to start, I need to initialize randomly the value of m and b. Okay, this is the process. Also, we have something we call it, learning rate. So learning rate is in fact going to help me to update the value of, for example, m and b or c. For example, let us assume I want to update the value of m. Now, how much I need to go and update? Shall I say, for example, 10.01? Okay, or shall I say that the next value should be 11, or maybe the next value need to be 100, right? How I will know my step, how far I need to go, right? This is where, the learning rate will help me either to have a very big step or very small step. Don't worry, it's going to be very easy the moment we go through the example. Fine. So the moment I assume, m and b and the learning rate, fine. If we are going to substitute m and b, the equation will be or will look like this. The equation will look like this. Correct? And then after that, what I need to do now, I need to check if this value of c and b, if it is good or not. So what I need to do, I need to calculate the error. How we will calculate the error? Using mean square error. So this is what we are going to do here. So this is the same equation which I have explained before. This is the mean square error. What I want to do is I want to see how much error this equation is giving me. Okay, the error means that it's going to represent how good is my prediction. Fine. So what I have here now, if I'm going to go with this mean square error, what is this value? This value is the y hat. Y hat means the predicted y. So here I have the actual y, and here I have the predicted y. The predicted y is what? Is in fact this one or this one, correct? So what I will say y, which is the actual y, which is coming from here, minus this equation, which I have it here. This is the y, this is the straight line equation, correct? So y is a value coming from my original data, and this is my straight line. And what I will do, I will subtract both to get the error, and the error will be squared. Fine. I will do this for all the observation. Let us see. So now what I will do first, 1 over n. N here is 7 because I have 7 observation. That is 1 over 7. And then the summation, and the first value I have for y is 800. So I will put here 800 minus the prediction. How this 600 was calculated? Very simple. What we will do, we will use this 30 and we will just substitute it here. So it will be 10 multiplied by 30 plus 300. If you are going to calculate it, it will be 600, okay, to the power 2 plus. 950 minus, again, 37 multiplied by 10 plus 300. Again, don't forget that 10 and 300, I choose them randomly. Only at the beginning. Later on, we will tune it. Tamam? So now what I have 950 minus 670. So as you can see, there is a, a sort of an error between the original value and the prediction. So let us assume that this is the salary. So instead of giving him 800, I am giving him 600. So there is an error between my prediction and the actual value, and this is what I am doing here. So we will keep on doing the same, okay, for each and every observation. Fine. And we will take the summation, of course, over 7. It's going to give me 74,000 or 74,500. Okay, this is the total error. This is the total error. What I want, in fact, I want to reduce this value. How it will be reduced? By tuning two values, which is B and M. By tuning two values. Let us see how now I can reduce this error. Please be with me. So for me to reduce the error, the first thing I need to do, and this is where we go more into mathematics, we are going to apply partial derivative. Don't worry, it is very easy. So what we have, this is my equation, correct? What I want to do, I want to do partial derivative in terms of M. So if I will do partial derivative, let us just look here, fine. And I want to do partial derivative in terms of M, or with respect to M, fine. So how much it will be? First of all, since I have a brackets and I have a power, this 2 is going to be here, and we are going to reduce 1. So it will be with power 1. So it was 2, we reduce, the power by 1. This is in terms of derivative, correct? So this is 2 and 1. And then after that, what we will do, we will look inside. Where is M? This is M, correct? What is the coefficient of M? Fine. It's X or minus X, correct? So this is why I have here minus, and this is my X. So again, what we do, if I have a square, a bracket, and I have a square, what it will be? It will be 2, and then the values, okay? Here we will have 2 minus 1, so it will be with the power 1. And then the derivative, yeah, it will be here. The derivative will be here in terms of M. The derivative of M will be here. Okay? So this is what I am doing here. What is the derivative in terms of M? It will be minus X. I have X here and minus is here. If we will calculate this, it's going to be what? Minus 2388.57142, etc., etc. Okay? This is what? This is the partial derivative of the error in terms of, or with respect to M. Fine. Now, what we will do, we will take that partial derivative or this value, and we will multiply it with learning rate. What is the learning rate? Again, it is 0.0001, and this is also going to be what? Going to be chosen from the beginning of my calculation. What I will do now, I will say M, which is the previous one. What is the previous one? It is 10, correct? Minus the learning rate. Everything here is given. What is the new? The new thing is what? Is the partial derivative of M, correct? So this value will be here, fine. If I'm going to do this calculation, I will end up with the 12.03. 12.03, it is what? It is going to be what? The new M, which is M2. This is going to be the new M. So again, how I can update the new value of M or the slope? By using gradient descent, I need to put the old value minus learning rate, which is going to be usually 0.1, 0.001, etc., etc. So we need to initialize it again randomly, okay? And multiply with what? With the partial derivative with respect to M, because I want to find the new value of M. I need to do partial derivative with respect to M. And here, as you can see, the value of M, it was equal 10, and after I have done this, now it is 12.03. So it is changed slightly, it is changed, right? And I will do the same now with what? With P. So if I'm going to do the same process again for the intercept, what we will have? We will have the same parameters here, but multiply with 1. Why multiply with 1? Because if I will come here, what is the coefficient of P? It is 1. So that's why the derivative will be 1. And the final value, if you will calculate it, it will be minus 497.142. Okay, again bringing that value here. So what we have the old value of p minus the learning rate multiply by the partial derivative of the error with respect to b. We will end up with this value. So again, what was the original value of b, which is b1? It was 300. And now after this, it is 300.0497. So there is also a small change between the previous and the new value. What I will do now, after I got the new value of m and b, I will again put it into this equation. And what I will do, I will calculate the error again. So I will calculate the error, which is the new error mean square. This is for the first iteration. Fine. And if I will repeat the same process, but this time using this equation with the new value of m and b, I will see that the error was reduced. The first error, if you remember, it was 74,000 almost. While now, after we have done only one iteration, means after we have changed the value of the parameter only one time, by using gradient descent, I was able to reduce it almost to half. Imagine if I will repeat this for maybe 10 times, for maybe 20 times. The error will keep on reducing because we will change the value of m and b until the error will reduce, right? This is how we can optimize or reduce the error and enhance the accuracy of my model using gradient descent for linear regression. So I will continue with more iterations until we reach to the best value of m and b, which will lead for minimum error possible. And this is what we call it optimal point, or maybe we can call it also local or global minima. This is now a summary of what we have done. So originally we were having these data only as a historical data. What I wanted to create a model which can predict the salary based on the age. So this was by choosing the first m and b, the slope and the intercept. And the moment I applied gradient descent, changing slightly the value of m and b, I was able to enhance my prediction. If you will see here, the value is supposed to be 800. For the first time, it was 600. When I changed the value of the parameter, now it is 661 almost. And you can check, for the other, observation, you will find the second one is much better. See here, for example, 950. First, it was 670. Now it is 745. For example, the salary is 600. Before it was 550, the prediction. When I changed the value of m and p, now it is almost the same, right? And you will see that always, the moment you apply gradient descent, you are reaching to a better model. Better model means, more accurate model. This is, the idea of linear regression using gradient descent. Now, linear regression can be used also by what we call it ordinary least square, and maybe I can create another small e-learning for that. But here I just wanted to show the idea of gradient descent, which is really sometimes it's tricky to understand it. Usually I hope that it was easy for you to understand it. So how you can apply this practically? You can of course use any kind of programming language like Python, R, maybe Java also, but usually we don't use it. If you want to know how it can be applied practically, you can attend our course, which is machine learning using Python course, where we explain how we can use it practically using Python. But I hope that when you are going to use this algorithm now, you have a sort of understanding on how it's really working from the background. I hope that it was clear. Thank you so much for attending, and hope to see you again in some other courses. Thank you.